Learning Objective 5.3 asks us to look at government policies to deal with externalities. In particular, we want to analyze government policies to achieve economic efficiency in a market with an externality.
We learned in a previous chapter, taxes create an inefficient outcome in the marketplace since economic surplus is reduced and deadweight loss occurs. However, we also learned in this chapter, positive and negative externalities also cause economic inefficiency as well. So now we will see how imposing a tax or providing a subsidy by the government actually leads to economic efficiency. We begin with the government imposing a tax to correct for a negative externality.
Whenever the market produces a negative externality or cost onto a third party, the government can impose a tax in order to lead us to the efficient level of output, which is what we will illustrate here in Figure 5.5. Recall, when we don't include the negative externality, we have an overproduction in the marketplace or at market equilibrium, like we illustrated in Figure 5.1. Thus, if the government were to impose a tax on this marketplace by an amount equal to the negative externality imposed onto that third party that's outside the marketplace, we can find our efficient outcome. So let's impose a tax on producers. This will shift the supply curve to the left. Now before we look at the new equilibrium point, remember, at our current market quantity, now our marginal social cost is greater than our marginal social benefit, which is inefficient because it also creates a deadweight loss. This will then in turn lead to a reduction in the quantity. So we move from our market quantity to our efficient quantity. Furthermore, the price level will rise. We started at our original market price and now we increase the price to our efficient price. Again, this is simply due to the decrease in supply due to the imposition of a tax to correct for the negative externality. But now that we've corrected for this negative externality, we have our efficient outcome. It's our market equilibrium plus the tax. Now let's look at the actual incidence or who pays the tax. Recall, when we impose a tax, we can look at the vertical distance at the efficient quantity, or the difference between the efficient price and just the generic price here, which comes off the original supply curve. That's the amount equal to the tax, which also happens to equal the actual cost of the negative externality, or in this case, the cost of acid rain due to the production of electricity. Thus, the amount the sellers receive is the price level P here, which comes off the supply curve, while the efficient price, that's the amount the consumer pays. Therefore, we see the cost of a tax on producers will be split between the producer and the consumer, which is needed to be done in order to correct for the negative externality caused in the marketplace.
So taxes internalize the costs associated with a negative externality back into the marketplace, which reduces the economically inefficient overproduction of the good back to an economically efficient level of production. But does the same outcome occur when the market produces a positive externality? In other words, if the market is producing an economically inefficient outcome by producing too little of the good, can the government provide a subsidy to internalize this positive externality? Let's take a look.
Now we can illustrate the opposite effect from Figure 5.5. When there's a positive external benefit, a subsidy can be provided by government in order to lead us to an efficient level of output, which is what we will illustrate here in Figure 5.6. Recall, without internalizing the positive external benefit, we have an underproduction in the marketplace or at the market quantity, which is what we illustrated in Figure 5.2. Thus, government provides a subsidy equal to the amount of this external benefit in order to achieve the efficient outcome. When the government gives college students a subsidy in order to internalize the external benefit to society, we see a shift or an increase in the demand curve, illustrated here. Notice, before we look at our new equilibrium, at the current market quantity, marginal social benefit is now greater than marginal social cost. This creates a deadweight loss and thus is currently inefficient. Due to this specific inefficiency, we would see an increase in the production of education. Thus, we move along our original supply curve to our new efficient outcome. We now have higher prices and higher quantity due to this increase in demand, which is due to a subsidy equal to the amount of the external benefit to society when students go to college. It's efficient because the marginal social benefit, which is the original market equilibrium plus the subsidy, is now equal to the marginal social cost,
the amount read off the supply curve.
The amount of the subsidy is located here off the efficient quantity, which is the vertical distance between the efficient price and the price off the demand curve D1.
The incidence of who pays and receives this subsidy is illustrated also by this difference.
At a price, P,
which is read off the original demand curve,
is the price paid by consumers or college students in order to attend college. The price efficiency is the amount received by the universities that provide the education. Thus, we can see whenever there's a positive externality, a subsidy can bring about the efficient level of output.
The last two figures illustrated examples of Pigovian taxes and subsidies, named after the English economist Arthur Cecil Pigou, who was the first to propose using government taxes and subsidies to correct for externalities and improve economic efficiency by eliminating deadweight loss. Many economists especially like Pigovian taxes, not only because they increase producer and consumer surplus, but they also generate revenue for the government that could be used to replace other economically inefficient taxes, resulting in a double benefit or dividend of taxation to society. Now let's see if we can answer the following question in the next video. Should the government tax cigarettes and soda?
Should the government tax cigarettes and soda? Here's the key point. The case for imposing taxes for negative externalities in consumption is actually less clear than for negative externalities in production. Let's go back to our economic treatment. Governments can increase efficiency by levying Pigovian taxes on products that generate negative externalities in consumption. Now, in practice, governments impose taxes, sometimes called sin taxes, on products such as cigarettes and liquor. And recently, several cities have considered taxing sweetened soda on the grounds that these sodas cause a negative externality by raising medical costs. Well, what's the externality? Well, people cause a negative externality by smoking and drinking sweetened sodas because the higher medical expenses from treating the complications of smoking or obesity aren't paid entirely by the smokers or soda drinkers. But health economists note there's an offsetting effect, because smokers and people who are obese do tend to die early. Now, economists and policymakers continue to debate whether the government should use taxes to deal with negative externalities in consumption.
Instead of using taxes to correct for the negative externality of pollution, the government can impose quantity restrictions on the amount of pollution allowed, which is described as a command and control approach to pollution. For example, during the 1980s, the federal government required automobile manufacturers such as GM and Ford to install catalytic converters in order to reduce the level of auto emissions. This is done by converting the toxic pollutants such as carbon monoxide and hydrocarbons in exhaust gas to less toxic pollutants such as carbon dioxide and water. However, the command and control approach to reducing pollution may not be economically efficient, since car manufacturers can have different costs when they equip their cars, trucks, and SUVs with catalytic converters. So if the government wishes to reduce pollution by a specific amount, requiring both companies to reduce pollution by the same amount would not be efficient. So let's assume Ford can reduce the carbon footprint of its automobiles at a lower cost than GM can. So requiring Ford to reduce their pollution by a larger amount than GM would be efficient. But would it be fair? No, because the government would be penalizing Ford by holding them to a higher standard than GM. So not only would it be efficient to have Ford lower its pollution by a larger amount than GM, but GM should also have to compensate Ford as well in order to offset GM's smaller pollution reduction levels. This results in both companies ending up better off by reducing different levels of pollution than they would have been if they were required to reduce pollution by the same amount. This is an example of a market-based approach to reducing air pollution from automobiles by setting up what is known as a cap-and-trade system. First, the government sets a targeted amount of allowable pollution or emissions. Second, these emission permits are distributed to the firms, for example Ford and GM, and they can be evenly distributed as well. Because third, firms are allowed to trade these pollution permits. So firms such as GM, who have relatively high costs to reducing pollution, can buy additional permits from other firms such as Ford, who have relatively low costs for pollution reduction. As a result, pollution is reduced in the least costly manner. Thus, the market is used to efficiently reduce pollution. Another example of a cap-and-trade system of tradable permits was set up by the United States Congress to reduce sulfur dioxide in 1990. As a result of this market-based approach, technological improvements to pollution reduction ensued, reducing the actual cost of compliance by 90%, from an initial estimate of $7.4 billion to only $870 million. Furthermore, the dollar value of the total benefit of reducing sulfur dioxide turned out to be over 25 times greater than the initial cost. However, allowance trading essentially ended in 2010 when the EPA replaced it with 4 separate trading programs under the Cross-State Air Pollution Rule. But the United States Court of Appeals for District of Columbia effectively shut down this new trading system, and as a result, the EPA returned to a previous command and control system. Although many environmentalists criticize the taxable pollution permits as simply a license to pollute, they failed to recognize the efficiency of the tradable pollutions permit. This system saved utilities and thus society more than $6.5 billion each year. That amount of saving from cap and trade could be used to reduce other types of pollution. However, there was also a concern that cap and trade would also result in hotspots of pollution. Do you think this is likely? Well, according to the EPA, the environmental results observed under this program showed that with a combination of a stringent emission cap with tradable permits resulted in a substantial reduction of pollution throughout the entire affected region, with the greatest reductions achieved in the areas with the highest pollution. In spite of the effective result, cap and trade has lost its popularity recently because it boils down to who bears the costs of pollution. When pollution is unregulated, consumers pay the price. When pollution is regulated, firms bear the cost, and typically, polluting firms hire better lobbyists than consumers, and thus may be able to persuade government against pollution-reducing policies such as cap and trade. In other words, it's the classic special interest problem in politics, and is the central argument of American economist Mancure Olson's book titled The Logic of Collective Action.